Hello students, this is Miss Dalton, and today we're going to be talking about non-linear inequalities. Okay, so let's look at our objective for this notes packet. So objective for today, for this lesson, the learner will graph non-linear inequalities, including parent function transformations, and decide if points are solutions. So to do this, it works exactly the same way as graphing linear inequalities, okay? The first thing you're going to do is decide on the type of boundary. So just remember, less than, greater than, those are both dotted lines. And then if you have a less than or equal to, or a greater than or equal to, then that is going to be a solid boundary line. Okay? Then you're going to graph the boundary, and you're going to choose a test point and shade. So let's look at our first example. Graph the singular inequality and the systems of inequalities on the next example. So this just is a single inequality. We notice that it is a quadratic, and for part A we're going to decide on the type of boundary. Well, because this is a greater than sign, it is going to be a dotted line. Okay, and so let's go ahead and graph this. You're going to notice that this is a quadratic parent function. So we are going to start with our table for a parent function quadratic, which was -2, 4, -1, 1, 0, 0, 1, 1, and 2, 4. Then we're going to do our transformations. Well, just remember, everything that is on the outside of the parent function, here's my parent function, the quadratic. Everything that is on the outside, so the 2 and then -1, that's going to affect your y value. So I'm going to put that here, 2y minus 1. Okay? Now, on the inside of the parent function, that's going to show what's happening horizontally. So I have a -3, and if you remember, horizontally will always be the opposite, so it's going to affect my x values by moving them +3, which of course is in the right direction. Okay, so let's go ahead and figure out what our new points are. 2 times 4, change my color real quick, sorry. 2 times 4 is 8, 8 minus 1 is 7, 2 times 1 is 2, 2 minus 1 is 1, 2 times 0 is 0, 0 minus 1 is -1, 2 times 1 is 2, minus 1 is 1, 2 times 4 is 8, minus 1 is 7. Okay, now for my x values. Your x values are going to be -2 plus 3, which is just 1, -1 plus 3, which is 2, 0 plus 3, which is 3, 1 plus 3, which is 4, and 2 plus 3, which is 5. So let's graph our new points on the graph, and this is so at 1, 7, 1, 2, 3, 4, 5, 6, 7. I believe it's right there. I'm getting dizzy when I'm looking at this graph. So let's count again. 1, 2, 3, 4, 5, 6, 7. Yes, that's correct. Okay, and then 2, 1. 2, 1 would be right here. 3, -1 would be right here. And 4, 1 would be here. And then 5, 7 should be even with this point up here. Okay, and so here's my quadratic. Now, before you just rush to draw your quadratic, always double check and see what kind of line you're going to be drawing. I'm drawing a dotted line, so let's dash my line a little bit as best I can. Okay, and then this one over here, a dashed line. Okay, and here's my quadratic. Now you can always check this on the calculator to make sure that you have graphed this correctly, but I still want to see your table, okay, because we're still having problems with these tables. The more practice we get, the better we get. Okay, now let's figure out where we're going to shade it. Well, this is a greater than sign. So the points that should be shaded are greater than this graph. Now what I always do is I put my pencil on the actual point, and then I'm just, greater than is going to be up. So it's going to be everything inside this parabola. Okay? And again, you can do a test point. If my test point is 0, 0, okay, then I'm going to plug that into my inequality. So I'll have 0 greater than 2, 0 minus 3 squared minus 1. So let's check it. 0 is greater than. 0 minus 3 is negative 3. Negative 3 squared is a positive 9. 9 times 2 is 18, so that would be 18 minus 1. So is 0 greater than 17? No, it is not. That is a false statement. So my point 0, 0 is right here. That is not part of the shaded region. So I'm going to shade here, and you can see that we already did that. Okay. So again, the test point just verifies that you have shaded in the correct area. Example 2. This is a systems of inequalities because there are 2 or more systems. So let's look at our first system. The first system has a less than or equal to sign, so I'm going to put the number one system is going to be a solid line. Okay, and let's go ahead and make the table for that line, or yeah, for that that line. Sorry, it is a absolute value. So your parent function table for the absolute value parent function was at negative 2, 2, negative 1, 1, 0, 0, 1, 1, 2, 2. Okay? And let's see what's happening to this one. Anything that is on the outside of my parent function is going to affect my y values. So I'm going to write those down. Negative 1/2 times my y plus 4. That's what I want to do to make my transformations happen. Okay, see if I can change my color. Okay, and then for my x values, those are on the inside, but remember they're going to affect the x values opposite, so it's going to be x plus 1 because it's going to be moving to the right. So let's figure out what these new points are. Let's do the red first. So negative 2 plus 1 is going to be negative 1. Negative 1 plus 1 is going to be 0. 0 plus 1 is 1. 1 plus 1 is 2. 2 plus 1 is 3. Okay, now let's look at the y values. So negative 1/2 of 2 would be negative 1. Negative 1 plus 4 is 3. Negative 1/2 times 1 is negative 1/2, and negative 1/2 plus 4 is 3.5. 0. 0 times negative 1/2 is 0, and 0 plus 4 is 4. 1 times negative 1/2, so you can see that's going to repeat because 1, 1 here, so this should be 3.5. And then the 2, we already found out what 2 was, and that's going to be 3. So now let's graph our new points. So at negative 1, 3, it's right here, and 0, 3.5 is right here, and 1, 4 is right here, and 2, 3.5, it's going to start to come back down, and so this should be my absolute value. And always double check, this is a solid line, so I'm going to go ahead and make it a solid line. I'm going to try and connect this as best that I can and draw a straight line, straight line over here. Okay, so that's as good as I'm going to get. And then let's see, it's less than or equal to, so it should be below this absolute value. Let me extend this arrow out just a little bit more. And so less than this function would be everything below it. Okay. Yeah, that's terrible. Okay, let's move on to the next one. So, number 2. the second equation for this system of inequality, second inequality. It is going to be a solid line also. And now let's make our table. So the parent function for this function is a quadratic. So you should remember what those points are. -2, 4, -1, 1, 0, 0, 1, 1, 2, 4. Hopefully you're starting to get these memorized by now. And now let's look at what everything is on the outside. Everything on the outside affects your y values. So we have 2y minus 3. And then on the inside, that is going to affect my x values in an opposite manner. So x minus 4 in my table should be x plus 4. Okay, so let's figure out what these are. -2 plus 4 is 2. -1 plus 4 is 3. 0 plus 4 is 4. 1 plus 4 is 5. 2 plus 4 is 6. Okay, now let's do the y values. 2 times 4 is 8. 8 minus 3 is 5. 2 times 1 is 2. Minus 3 is -1. 0 times 2 is 0. 0 minus 3 is -3. 1 times 2 is 2. Minus 3 is -1. And then it should repeat. This should be a 5. So let's go ahead and graph this. This time I'm going to graph it in red. So 2, 5. Let's try and find that. 2, 1, 2, 3, 4, 5, I believe is right there. It's getting late and I'm having a hard time seeing where it is on the graph. And then 3, -1, 2, 3, -1 would be down here. And then 4, -3 would be here. And then I should start to come back up. So this is going to be at -1. And next we'll be at +5. Alright, so again, this needs to be a solid line. So let's try and draw my solid line. My solid parabola, I should say. Okay, that's as good as it's going to get. And then because it is a greater than or equal to sign, it's going to be everything above this parabola. So it's going to be on the inside of this parabola. Alright, so hopefully you can see where our solution area is. Let me just go ahead and black it in. Our solution area is going to be everything that's in this region right here, because it's going to be the double shaded region. Okay, so again, if somebody asks you, is a certain point a solution? Well, it better fall in this solution area for it to be a solution. If it doesn't fall in that solution area, then it's not a solution. So you just say, no, it's not a solution. Okay, let's move on to number 3 and number 4. So what I want you to do right now is I want you to do number 3 and 4 on your own. And when you come to class tomorrow, that is going to be how we begin class. So please get that done and come to class tomorrow. I'll see you then. Have a good evening.